Okay, I'm going to do a pre-lecture for the last two and do a review of the first three that we did. So if you already comfortable with the first three, you're going to be fine. You already did the first three in the homework, you're going to be fine. But let's just review those just for anyone that might want to review. Related rates, we had three related rate questions that we already talked about. The first was the sphere. The volume of a sphere is 4/3 pi r cubed. Now don't worry, you learned that back in freshman year, and you may never have used that formula since. We're using it again. I'm going to give you the formula. Okay. We talked about that. That's one of the things that makes related rates hard is if you don't remember the formula. But don't worry about the five. I'm going to give you like 10 related rate questions. The five that I'm going to put on the test, I will let you know what the formulas are, and that actually really mitigates the difficulty of the question. But that's okay, because the real thing that I want to get at is this idea of the implicit differentiation on the R and the V and on the letters here. And now remember, what we're going to do is we're going to take the derivative with respect to time. So we're not going to call the derivative of V1, we're going to call the derivative of V the derivative of V. And then remember, the constant is just going to sit there because in the product rule, the derivative of the constant is going to be 0. Okay, so then the derivative, normally this derivative would be 3r squared r prime. So that was the first one. Now keep in mind, when you read the question, they're going to either give you v prime, r prime, and r prime. They're going to give you two of the three, and you got to find the missing one. And I think the example I did, I gave you the rate of change of volume, and I gave you the radius, and you had to find. In the example I did, you had to find r prime. But it just depends on the question. So that was the first one we did. The second one, I'm not actually going to do a question. I'm just going to give you the first two steps, okay? Just because I want to kind of just remember this is just a review. But on the next two that I want to put up after I do this, I'm going to do a video on the next two, and I will work out an actual question. Okay. The second one we did was the cone with water in it, and the water was leaking out. Now, again, you might not remember, but the volume of a cone is 1/3 pi r squared h. Now, what we talked about is I'm not going to use any cone for this class, and only this class. The cone I'm going to use is always going to be where the height is twice the radius, or the radius is half the height, right? If I'm twice as old as my brother, then my brother is twice as old as, I'm twice as old as my brother's half as old as me. So now what that does is that's going to eliminate one of the variables, and we talked about this. The reason you want to eliminate one of the variables is in the question, they're only going to be concerned about the height in the tank, okay? We're not going to worry about the radius in the tank. Not that you couldn't, but I'm going to limit our questions for this, the cone question, to that. Now what that does is I can, where there's an r, so what that means 1/4 h squared is, if I square both sides here, I can substitute that in. And so I get v is 1/12 pi h cubed. 1/3 times 1/4 is 1/12 times the pi h squared times h cubed. This is the formula we're going to use. In this class, the formula for the cone will always be, in related rate questions, will be 1/12 pi h squared. And notice that we've completely eliminated the radius from the question, because we're not going to worry about how fast the radius is growing. We're going to be worrying about how fast the water level is growing up, okay? So now, we're going to do a question later where we do have the extra variable. Actually, we're going to do two of them, but we're going to do one where you have to do a product rule. That's one of the ones I waited on, okay? So in this question here, what we're going to do is we're going to remove a variable. which we didn't do in the last one. Each of these questions has a little subtlety to it, and we ramp up the difficulty a little bit each time we go through one of the questions. So the first question, we just know the generic formula. We just take its derivative. In this one, we have to modify the formula. Now keep in mind, later on in college, you might get a cone that's got a different ratio between the radius and the height. But for us, it's always going to be, the height is always twice the radius, generating this equation. And then, remember how we take the derivative? We say the derivative of v is the derivative of v, not 1, because the time is the variable. This is called a parametric equation. And what that means is the thing that's changing is time, but the equation doesn't have time in it, so we have to do implicit differentiation on all the variables in this question. And then remember, this is kind of a weird constant, but it just sits there. 3h squared h prime. And the same thing. In your homework, I'm going to give you questions where I'm going to have to give you the height, and then I'm either going to give you how fast the water is being poured in, or how fast the water level is rising up, and then you have to find the other one. Like, if I give you the height and the v prime, then you have to solve for the h. If I give you the height and h, you have to solve for the v prime. Okay. So this is the second type of question that we did, and we did an example of it. But since it's just a review, I'm not going to do the example. I'm just going to give you the formula because you just got to plug the numbers in. Okay, the third one we did was Pythagorean theorem. X, Y, Z. Some people might use X, Y as R because you had trig and we always X squared plus Y squared is R squared. It depends. It doesn't matter. And you could use A squared plus B squared is C squared. It doesn't matter. The letters are not important. So what I get here is X squared plus Y squared is Z squared. Now why is this different than the other two? Because there's a third variable, which means I got to give you a whole bunch of more information in the question. Okay? It's not hard. It's just that oh crap, now I got all sorts of stuff to deal with here. Well, I mean, got an extra variable to deal with. So what do I get here? 2x times x prime, 2y times y prime, 2z times z prime. Remember, normally the derivative of x squared is 2x. Normally the derivative of y squared is 2y. Normally the derivative of z squared is 2z. But because of the implicit differentiation, that what's changing here is time. Remember we had an airplane flying away from us horizontally. And this is the equation. Now, normally we divide by 2. That's kind of a crappy y prime. Z prime. But notice in this question, unlike the other two, like remember the other two, I just got to give you 2 of the 3. Here I got to give you 5. I got to give you 5 of the 6. But remember what happens here, I don't actually give you, like the other two, I kind of give you those numbers. You don't have to infer them at all. Here, there's some inference, right? You kind of have to infer something here. One of the main things is one of the sides is probably not moving. It's staying constant. And remember the derivative of a constant is 0. So one of these derivatives is probably going to be 0. It doesn't have to be. Matter of fact, you'll have a question where I actually give you all 5 pieces. But keep in mind, sometimes I don't give you all the pieces. Sometimes, because of the Pythagorean theorem, I'll give you 2 sides of the triangle, and you've got to find one of the missing sides. So in this one, it'll seem like I'm only giving you a couple pieces of information, or 2 or 3 pieces of information, but you can infer a couple of them. And so just be aware that what we do then is you're going to be looking for one of the derivative. It's always the derivative you're looking for, either x prime, y prime, or z prime. And I'm going to give you x and y and z. Now I'll probably only give you 2 of the 3, and you got to figure out the third because of it's a right triangle. And then I'll give you one of the rates, and then one of the other rates will probably be 0. That, or I'll give you 2 rates. Then you got to find the missing one. Okay. So anyways, you have those examples from last week. These are just, remember, the 3 formulas that you're going to need for your homework. You're going to have a question, x squared plus y squared is z squared. It's probably the airplane flying overhead question. And then you're going to have a cone question in the assignment where water is either... actually in this one, the cone is upside down and there's sand being poured down on the cone. So, but keep in mind, that doesn't matter which direction the cone is. The cone is still the same, and so the derivative is still the same, and so the numbers are still the same. The cone, but in this case, the height of the sand is growing because they're dumping sand on a cone, and, oh sorry, they're dumping sand and it's forming a cone. But it's the same as the water question. And then you'll have a question where you have to deal with the circle. Now keep in mind they give you the diameter, so you gotta remember to divide the diameter by 2, okay, to get the radius. Or if they ask you for the diameter, you have to get your answer in radius, the radius prime, and then multiply the answer by 2. So you either divide by 2 or multiply by 2, depending on whether you're looking for the radius or diameter. It's kind of like why the Tau day thing all over again. The question I give you actually asks for the diameter, which just messes us up because of our formulas in terms of the radius. So, anyways, those are the 3, just kind of reviewing. I was going to just start with the last 2 examples, but I thought I would just do a little video on the first one. Okay, thanks.